Assalamualaikum and good afternoon. Okay, so today kita proceed lagi with chapter 4 Reinforced Concrete Foundation Design. Example number 2. Because last week kita dah buat example number 1 in tutorial class. Okay, but we haven't yet finished, but we're going to proceed it in our tutorial class again this week. Okay, but we just proceed with example number 2, okay, for today. A column of 350 times 350. So this one is basically going to be the size of the column. So we're going to mark it as C. Okay. Column width carries a dead load of 800 kilonewton. So this is GK. An impulse load of 400 kilonewton QK. The safe bearing pressure is 200. So this is PB. Design a square base. So square base minta to resist the loads. The concrete grade is 35. So this is FCU. And reinforcement grade is 460 FY. The condition of exposure is moderate for non-aggressive soil. Nominal cover is 40 mm. Again, this is C, but referring to concrete cover. Cast against blinding. So nothing else given. So bila dah tak ada anything else given here, you are forced to assume. So kita akan assume throughout our design for this example. So first, we need to assume the footing weight. Macam like example number 1, the assumption is were given. Okay, a few assumptions were given, then you just use whatever based on the assumption. Okay, but if it's not given, you can assume lah. So here I assume the footing weight W is 80 kilonewton. 80 kilonewton saja. I assume your assumption actually can go up until 100 kilonewton, 120, 130 kilonewton, up to you. But that is basically your assumption. But here I just assume the lowest. Okay, so we need to calculate the serviceability load. So 1.0 GK plus 1.0 KK plus 1.0 W. So this is the formula for serviceability load. 1.0 here referring to the factor of safety. So you masukkan saja the value of GK and QK, and W 80 kilonewton ni is W that we assume. Okay, if you assume different value, so you're going to put a different value here. Once I dah assume everything and I add all, I get 1280 kilonewton. So from serviceability load, we can finally find the size of base. How are we going to do that? We're going to divide the serviceability load divide by bearing capacity of soil, which is PB. So 1280, we know that from the question again, PB adalah 200 kilonewton per meter square. So you will get 6.4 meter square here. So based on this value, I square root kan. Okay, I dapat, when I square root this value, kan 6.4 meter square, I square root kan. To get each size because of the whole area of your foundation here, basically it is 6.4 meter square. So you nak dapatkan satu side ni berapa, satu side ni berapa. So we can just square root kan dia, because basically Ly darab dengan Lx adalah sama dengan 6.4 meter square. So you nak dapatkan Ly saja atau Lx saja, so you just square root kan sahaja. Okay. I dapat 2.53 lah. 5298 kan. Okay. So when I square root kan, I dapat this kind of value. I'm not going to round it down. Whatever it is, you kena round up. Okay, this is like the minimum value for the one that you assume footing weight dah 80 kilonewtons, blah 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 blah. So 2.53 meter ni adalah minimum value. You cannot go lower than this. So that's why I round it up become 2.6 6 meter. We can round up to 2.7, 2.8 is what I explained in example number 1. It is according to your how you going to round it up. But because later on we need to check it. Okay. And again, we have to assume the overall depth of footing because this one is also assume. Okay, ini semua assume kalau you tengok because dalam soalan langsung tak ada bagi any assumption for you. So you have to assume on your own. So I just assume here is 500 mm. Just make sure that you don't assume it too low because foundation normally dia tak senipis slab. Okay, because of foundation normally is a heavy thing. So dia lebih tebal lah. So 500 mm ni lebih kurang separuh meter Kalau you tengok 1 meter tu 1000 mm kan. Dia separuh meter lah. Separuh daripada 1000. So quite thick And then we need to check. So self-weight of footing is this one for checking. Okay. Kita nak check whatever that we assume, is it correct or not? You know that to get the weight, the self weight, biasanya kita akan darab the unit weight with the volume. So area time H ni adalah volume times 24 kN per meter cube. So 6.76 ni is based on the size of base yang kita kira the area. Okay, because volume is B darab D. Sorry. Lebar darab panjang darab tinggi. Okay. So 6.7 sini. So basically you punya foundation like this kan. Okay, this is 2.6 and the thickness is 0.5 meter based on your assumption. And you will get 81.12 which is bigger than what exactly you assume earlier. Sebab kat sini dia assume 80 kilonewton ini. Okay, here you assume it is 80 kilonewton though you dapat 81. Okay, so it is not okay. So what we need to do next is we need, okay, inilah yang macam saya cakap, bila you are forced to assume, sometimes this is what to happen. You have to redo. Okay, you have no other choice but to redo. So here I reassume footing weight. I do the same thing again. But I just change the weight of footing to 100 kilonewton. Okay, so here my W is 100 kilonewton. And then I calculate the size of base again. And I dapat 2 point, when I square root kan, because LX is 6.5 meter square. Okay, so LY is exactly sama dengan LX, which is 2.549 kan, 549 2.55 meter. Okay, so I round it up to 2.6 meter. Actually sama je kat sini. Dia tak berubah sangat pun, but you still have to kira because sebenarnya dia tak berubah banyak sebab you ada round up kat sini kan. Kalau katakan you masih lagi pakai 2.53 ni, so you memanglah lain lah. Okay, but here it is actually 2.55. Okay, so you round up dia 2.6, so sama je kita punya base size. But just remember kita ada assume footing weight 100 kilonewton. And overall depth of footing I masih lagi assume it is 500 mm. Okay, and again I have to make sure that it is not exceeding the self weight that I assume, footing weight yang I assume earlier. So 6.76 is based on the area. I darabkan dengan dia punya height again to 24 and I get that 81.12, which is salah ni, typo, less than 100 kilonewton as what has been assumed earlier. So which means it is okay. Okay, so after that we can actually proceed to the next step. So what we do next is kita kira dia punya ultimate load. Okay, ultimate load is using the formula of 1.4 GK plus 1.6 QK. So masukkan saja the value of GK from the question and QK from the question. Then you get 1760. And we need to calculate the ultimate earth pressure, which is basically this is the load yang being transferred, yang going to be transferred from the column to the foundation 1760, including the factor of safety lah. 1.4, 1.6 ni is factor of safety. Kita mesti provide extra just in case. So mesti ada factor of safety. Tak boleh design cukup-cukup We might not know what might happen. So kita kena provide some additional safety apa orang kata additional design, additional allowance for safety. Okay, so I dapat 17 from this 1760. So sebenarnya we have that one because we need to spread the load to the area of footing, sebab this dia load daripada you punya column here going to be transfer to the footing ni. Okay, so kita pun tengok because of the area of footing is actually 6.76, so 1760 ni kita kena divide lah dengan the whole area of the footing. So basically what is mean is 1 meter square of footing will be transferred as much as to 260.355 kilonewton. Okay, dekat footing ni lah. Okay, and from that we can finally find the moment at YY. So where is YY? So here is YY. Why we need to calculate this YY? Because this is the critical area for bending. Okay, so using this formula, masukkan je the value of PS. LY ni is the dimension of footing tadi yang dapat 2.6 meter times 2.6 meter. So this is LY and LX tak kisah mana satu sebab it is a square footing. So basically dimension dia sama. And masukkan je pakai formula LX minus C and LX again minus C, but one of it divided by 2, another one divided by 4. Okay, so 2.6 C here referring to column width. Okay, given the question 350 times 350 column width. So ini bukan concrete cover, bukan 40 mm it is column width. Same goes kat sini pun sama. So 0.35, this is column width. Okay, so the one yang I actually draw here, not really draw lah, whatever that shows you illustrated here is 1125 ni apa. Okay, so 1125 ni is actually the one yang ini adalah 1125. I kira lah, I letak lah kat situ, I level. Okay, you just try to calculate. Okay, bila I kira ni I dapat 1.125 and 2.6 minus 0.35 divided by 2, I dapat 1.125, but that is in meter. But in millimeter, oh man, dia hilang sebenarnya ni. Ni bukan saya typo ini Microsoft Word suka menghilangkan perkataan bila dia kotak dia tertutup. So ini adalah dalam millimeter, 2600 and 1125 millimeter. Okay, and 2.6 minus 0.35 meter divided by 4. So basically from 1125 ni you bagi je lah 2. So you dapat lah this distance. Okay, daripada centroid of this area nak pergi ke YY, because it says here moment to YY. Kenapa kita kata that is the critical area? So basically sebab you ada line ni, YY ni line yang paling critical, sebab you ada force that coming from above. Okay, dekat this point betul-betul dekat tepi kolom ni, dia akan transfer to the foundation, and your foundation also memang orang kata itu memang betul-betul berada dekat line dia. So kalau biasanya akan crack tu kat sini lah. Okay, the one yang sambungan, because yes, dia adalah sambungan so it is actually critical at that part. So when I calculate and everything, I will get 48.365. So this is moment at YY. And after that, what I need to do before I proceed untuk terus design for the shear for the bending reinforcement. Okay, maksudnya I nak dapatkan AS, I nak dapatkan how it's going to be distributed and the arrangement of distribution and also how many numbers of bar and the size of the bar. Before I proceed to that, I need to check for the preliminary check for shear first. Okay, why we need this? Because we don't want that we proceed calculate everything and all of a sudden our design is not actually cannot, okay, tak boleh nak support nak support any shear, okay, ataupun dia tak boleh resist any shear. So as what we need jadi kita kena check dulu, and to check it, so D is equal to H minus dengan diameter of bar. So we know that the formula again is H plus D plus full bar plus C. So please check on the example number 1 punya I explain, so you can check the video. I belum upload lagi. Sorry, I akan upload today, so you boleh check the video tu so that you will be understand mana datang this formula. Okay, but because we actually want to find the value of D, why we need to find the value of D? Because we have this formula. Okay, so this formula sebenarnya kita nak check D, so we must make sure that whatever value that we get here must be less than the D yang kita dapat from this formula. Okay, value D here, D yang kat sini, D here, okay, yang D here mesti lebih rendah daripada value D yang kat atas ni. Okay, so H is here basically it is from the assumption that we made. We assume that the height of the footing is 500 mm. Okay, ini assumption kita proceed je, pakai je assumption kita. Okay, so 500 and diameter of bar, so here I assume it is 16 mm. Okay, so diameter of bar it is 16 mm, and as what I already pernah tegur, bila kita assume, make sure it is based on bar size ini you jangan assume lain-lain. And basically kita takkan assume size yang terlampau besar, because we know that footing dia ada banyak size. And kalau macam dalam example number 1, if you still remember, siapa-siapa yang ikut dalam kelas tu, I pernah cakap yang if let's say footing kita akan risau kalau bar dia terlampau berjarak, kita bukan risau bar dia terlampau dekat. Okay, because of bar dia punya area dia besar, okay, panjang lebar dia panjang and everything. So kita tak risau dia tak ada area, maksudnya tak cukup gap for concrete to actually fill inside. No, we don't worry about that. We worry that the bar is too far apart, that is actually will cause some cracking and such, yang will cause like a serious fatal problem later on. Itu yang kita risaukan. Okay, so kita takkan ambil size terlampau besar-besar. So basically what we always assume, kita akan pakai 16-20 macam tu lah. Okay, for foundation, for pad footing, you jangan samakan dengan different type of footing, because what we learn today is pad footing only. So 500, this 600 mm, this is I assume 500 mm ni sebenarnya is what you assume juga, tapi you assume earlier. And 40 mm this one given concrete cover, bukan column width, yang letak 350. Okay, this is column width, concrete cover. So here I dapat 444 mm. And then I check, okay, using the formula of D equal to 8 square root N. So N here referring to ultimate load, bukannya serviceability load. Is a bit confusing because sometimes all this what I'm going to call it, it's not really a symbol lah. It's something like abbreviation, no, simbol lah sebenarnya. Okay, kita N ni kita namakan, it can be anything lah, but here it referring to ultimate load. So 1760 square root and you darab dengan 8, you dapat 335.619 mm, which is less than this value 444, maksudnya okay. Okay, because macam mana pun you punya, kalau katakan you dapat more, so ada something wrong dengan you punya design. Okay, sebenarnya lah. Okay, so we redesign from whether you have some sort of miscalculation ataupun memang design you teruk, which is weird. Okay, after we dah check, so basically it is okay. So kita boleh proceed to calculate for AS. Okay, kita boleh calculate AS using the formula of K, Z and AS. So K, when you calculate K, formula masih biasa, but here remember M, here tak ada M equal to WL square over 8. We will never use that formula inside foundation. We're going to use MYY, the one that you calculated masa ini. Okay, here. This is MYY, so you're going to use this formula. Pakai value MYY to put inside this formula and divide with the FCU given in the question. And B, kita dah calculate the size of the footing is 2.6 meter times 2.6 meter, meaning kalau dalam mm 2600. And D, kita dah kira when we calculated the preliminary checking for shear. Ini adalah value of D, 444 mm. 444, yes. Okay, so masukkan saja, you akan dapat 0.024 something lah. But here 0. I tak sure lah berapa, tapi I dapat inilah. Okay, and we going to calculate the value of Z. So as usual masukkan, and when we actually find the value here, we're going to compare with 0.950, and what you see here, this value of Z is bigger than 0.95D, so we're going to use 0.95D when we calculate for AS. So this is what you see here, 0.95. And M 428.365, masukkan lagi dalam formula of AS here. So I dapat 2323.946. So that is the value of AS. Okay, so basically what we can do is sebenarnya kita boleh terus cari the suitable size of footing. Sorry, the size of bar for the footing, okay? For the footing, the size of bar for the footing, and how many numbers of bar and such. But we still don't know the arrangement of bar. Maksudnya macam mana you nak arrange bar tu, whether it is going to be uniformly distributed ataupun it's going to be concentrated at certain areas of the footing. Similar to example number 1, kita kena tengok the distribution of reinforcement. Seperti tadi as I said, the arrangement of reinforcement tu macam mana. Okay, using the formula of 3C over 4 plus 9D over 4. Okay, so 3C, you see here referring to column width. Okay, just remember, kalau you nak senang lah, dalam foundation ni memang C ni ada 2, which is column width and concrete cover. Anything kalau ada formula yang H equal to D plus formula macam salah. Formula ini saja yang you pakai kalau C ni adalah concrete cover. Yang lain-lain semua adalah column width. Okay, ini saja concrete cover. Yang lain-lain column width. Here it is column width. Kira I dapat 1261.5. And I'm going to compare with LC. Tengok mana satu lagi besar. So the LC here, we know LC is actually LX minus dengan 2. Okay. LX is 2600, which is 2.6 meter tadi. Okay, 2600 divided by 2, I dapat 1300. But here, I dapat LC is actually bigger than 3C over 4 plus 9D over 4. I dapat like this. So, macam example number 1, LC kita lebih rendah daripada value ni. So, kita can simply say that it is uniformly distributed. But here, in this example, so untung you lah sebab ada example yang macam ni. LC here, I dapat lebih besar. So, dapat lebih besar, kita takkan nak redesign balik. Kita takkan buat apa-apa yang macam tu. Kita akan buat some sort arrangement pada our reinforcement. So we know that 2/3, apa maksudnya bila you dapat macam ni, maksudnya kalau this is your foundation, okay, 2/3 daripada, so it is here, it is 1.5D. Okay, 2/3 daripada AS akan concentrated dekat area ini. Okay. And kat sini ada 1/3 saja balance dia lah. 1/3 AS Okay. So 2/3 kita pun ambil ini adalah value AS. Okay. 2/3 pada AS you dapat 1549.297 mm square. Okay. And 1.5D maksudnya kita nak cari kat mana sebenarnya yang AS tu concentrated, maksudnya dekat this area. Okay, 1.5D from the face of the column. 1.5 darab dengan D kita is 444 mm, which is 666. Okay, you darab you dapat 666. So here I round it up to 670 mm lah. Because it doesn't make sense kalau you letak 670, 666 kat situ. So better kita round up 670. And I refer pada table. I tengok value I dapat here 1549.297. 1549.297. 2/3 AS okay, so this one yang akan concentrated dekat face of the column up until 1.5D from the face of the column tu. Okay. I refer dekat this table. So we know that earlier kita pernah ada buat assumption masa kita kira D. Kita ada pernah assume, okay, that our apa nama dia? That the size yang kita akan pakai untuk design, maksudnya size of reinforcement kita pakai 16 mm. Okay, so here I highlight 16 mm. So we can basically choose from 16 mm ni sebab kita pernah buat assumption. Kita jangan ambil size lain sebab that's why kita must remember whatever assumption that we made so that kita akan select size yang bersesuaian. So from this 16 mm size of bar, so you tengok 1549 ni, which one yang suitable? You can ambil 8Y16 1610. Okay, ambil size lebih besar lah. So here I select 8T to Y lah. Sebenarnya ada this one ikutkan tree masing-masing, and kat Malaysia pun ada orang pakai T juga Kali yang pakai T juga sebenarnya. So tak salah you pakai T. 8T16 8Y16 sama saja. So 1610 mm square because high tensile steel. Ingat bila macam ni you nampak YT ni, you kena refer pada soalan. Kan kalau kita kira FY tu 460, kita tahu dia high tensile steel. Okay, kita kena tahu. Jangan letak R kat sini because dia pakai high tensile AS 1610. So where is actually located 670 mm from the center line of the column. So sebenarnya ini daripada sini sampai sini 1.5D juga kat sini adalah 8Y16 ni duduk dekat sini, dekat sini 1.5D kat sini, 1.5D kat sini, 8Y daripada sini sampai 1.5D untuk the other side pun sama juga, and also kat sini side kat sini pun sama. Ini 1.5D kat sini ya, sampai sini 1.5D pun ada 8Y16 ni juga. Ini semua. Okay, so itu maksud dia. So kita check spacing, not exactly checking lah. This one kita nak tahu spacing dia berapa. 1690, this is the area, so minus dengan 8/16 mm divide by, kenapa kita tak ada tolak dengan concrete cover, because basically ni dekat tengah-tengah ni dia tak ada kaitan dengan concrete cover langsung. Okay, betul-betul dekat tengah-tengah, so tak ada tolak concrete cover here. Okay, perasan ini daripada 670 ni. Okay, sebenarnya kat sini ada salah kira sikit, sekejap ya. Okay, sebenarnya ni tak salah kira. Saya mabuk. So 1690 ni is basically mana dapat 1690 ni. Tak pernah jumpa value 1690. So 90 ni sebenarnya ini jarak ni. Messinya. Okay. Because you know this is like 1.5D. 1.5D, both side sama jarak daripada sini ke sini. Okay, because you know 1.5D adalah 670. This one also 670. This one must be 350 sebab kita punya column ni 350. So 670 darab 2 campur 350, you akan dapat 1690. Okay. And then minus dengan, sebab kita ada 8 numbers of 16 mm diameter of bar, and divide by 7 because jarak dia so kalau letak 8 number kat sini kan, so in between ni, so jarak ni because of mesti ada 7 space sebenarnya, so kita divide by 7, so dapat 220. Okay, so kita dah siap untuk yang dekat tengah-tengah, but what about the another one third of AS, so kita kena design on that part also. So untuk 1/3, so 1/3 daripada value 2323.946, which is your value of AS, you balik. Okay, you akan dapat 74.649. Okay, jadi kita nak design macam mana, kita kena refer by table, kita balik 774.649. This one untuk 1/3 masih lagi 16 mm. So here I ambil 804 ni lah. Okay, mesti lebih besar pada value ni, pada value of AS yang 1/3 ni, 1/3, 1/3, 804 mm. Okay, so here I pun ambil lah for Y ataupun 4016 suka hati sama juga lagi spacing ni. Okay, 910 ni datang pada mana? So you tahu sebenarnya jarak yang dari sini ke sini adalah 1690. Okay, and then we have the balance of yang ini dua ni lah. Okay, so of course you tahu 2600 tolak dengan 1690 lah balance dia, so dapatlah that 910 mm. Okay, so kat sini lah datangnya 910 tu. Okay, 2600 minus dengan 16 berapa je tadi, 1690 ni, so dapat 910. And because of one number sama, memang kenapa pula kita bagi macam ni sebenarnya. This is like simpler way lah. Okay, so this is like 1.5D sampai sini, 1.5D sampai sini. 1690. So you ada balance this one sebab you nak dapatkan here and here kan. Okay, so you ada panjang 910 balance because you have 4 numbers of bar minus dengan 16, and still you have like concrete cover at the end of this foundation. So darab 2 darab 40, so mesti ada lah concrete cover tu because of ini you dah kira yang kat tepi. Okay, so you bagi 3 because of 4 numbers of bar minus 1, and you dapat 255 ni, which is you round it down, because macam mana pun spacing kita round down, kita jangan round up. Okay, sebab lebih dekat lebih bagus, bukan lebih berjarak lebih bagus So ini adalah maximum value, mesti lebih rendah. So the bar can be equally spaced at 250 mm center. So maksudnya bar yang kat sini, kalau you compare, ini 250 the one yang you kira yang dekat tengah-tengah ni, yang lebih critical ni, 220. Maksudnya 8 numbers of bar ni lebih rapat. Okay, and at both side, kanan dan kiri dia lebih berjarak 250 center. So that is the function. Okay, and when kita dah dapat numbers of bar macam mana, we finally can calculate for the anchorage. So anchorage using the formula of 37 times diameter of bar. So 37 darab 16 dapat 590, but kita round it up to 600 Okay, so that is our design. Okay, I'm going to stop here. So about the vertical and transverse shear and also punching shear that we're going to check later on, I akan proceed dalam my second part of video today also I will release. Okay, thank you. Have a nice day everyone.